We study computing at Surbiton High School because computing is a fundamental area of study for all of the students going forward. It's unavoidable in their careers, in their lives, that they will be in a position where they don't need computing or access to computing software or hardware. To empower and encourage them to feel comfortable with computing technologies of the future, we have to embed some of the basic skills and to give them the confidence to explore these softwares and hardwares even further. We teach computing at Surbiton from year 7 right through to year 13, and we have several students who've moved on into university courses around this subject area too. It's often seen as a little bit of a male subject in some schools, and we're finding that more and more we're overcoming that stigma and finding those students, those girls who really, really are comfortable in the world of computing, having the confidence to take it forward. GCSE Computer Science from AQA. We have been running this course for a number of years now. It's been very successful. We often have student numbers around 20 to 25 taking the course, which is incredible. And the course itself is broken down into two very specific areas. The first area is programming. Now, programming is a skill that is needed prior to coding, if that makes sense. We teach the girls about algorithms, we teach the girls about flow design and problem solutions before they begin to code or create their solutions. So 50% of the course is specifically oriented around programming. The other 50% of the course is on computing theory, where they will begin to understand concepts such as computer networks or cybersecurity, or other areas of computing that are quite broad and can move in many different directions. So paper 1 is very much algorithms, computing design, the program design, and paper 2 is very much computing theory. We have NEA tasks as well, so the girls will be asked to create a solution for a task set by the exam board, and they will be given 20 hours of their own time to develop as best they can a coded solution. This will be different for every student, and it's just a measure of what could they do given 20 hours. And they will have all the support they need to gain the skills prior to that problem-solving task. It's an excellent opportunity for them to do something by themselves for the first time with code to really figure out and solve a problem. The department offers several opportunities for co-curricular clubs aside from support for our GCSE and A-level students in the course. We look into robotics at years 7 and 8. We have some robots that they can come and build and then code using their iPads, which is really, really useful, and using a program called Swift, which is from Apple. So we don't cover Swift in our year 7 to 9 course, but they can do it as a co-curricular opportunity as well. For GCSE and A-level, we run trips to Bletchley Park, and we're looking into trips to Silicon Valley in America. And our A-level students will take on a robotics challenge course at Southampton University, where we mix with DT and physics students to come together to build a robot that will work by itself at the competition, hands-free, and will try to solve the problems presented that we don't know before the day. So it's quite an incredible feat for them to put together this competition, as I said, with physics and DT. Other opportunities continue to arise for the subject with cybersecurity, using the government's cybersecurity competition for students aged 11 to 16. Many of our students have made it through different stages of the cybersecurity competition and have been invited to London for further competitions. So we're running many competitions simultaneously and robotics. Computing for us in the department, we come at it from very different angles. So we have Mr. Thornton in the department who has been a programmer, Mr. Eakins who's been an incredible programmer in his time. My background in computing was in the hardware, physical side of computing, and motherboard building, hard disks. And so together we have been almost training each other and finding new passions for our subject. But what we really love about our subject is the very fast evolution of its content and its expectations, and the new courses coming at university all the time that we're intrigued to find out more about, to encourage the girls to go off and read and come back and tell us and educate us too.